tool for integrating LON talk networks. Some characteristics of the channels that we're targeting at the moment. Currently, we're doing the 868 channel, which is for Europe. Well, of course, it applies for Africa, former USSR as well. The transmission power is limited to 20 milliwatts. But that gives us a peer-to-peer distance between the controllers, between the different nodes, of about 300 meters in air. So if you're in a building or if you have some other interference, that will be less than that. But this is the fastest as you can get. And of course, with the mesh technology, you're able to connect to devices that may be a couple kilometers away. Then, of course, you need to have a couple of hops, and I don't think we don't have the hops in here. I think 255 hops are supported. This will, of course, have an effect on the latency. Latency may be as low as 10 milliseconds per hop. What we have seen is that we're more at 40 milliseconds per hop, so that limits our the number of hops that we can actually do if we want to have acceptable latency times. With the test that we have run so far, we were at 10 messages per second. That does not sound like a lot, and this is the reason for this is the regulations we have to comply with in Europe. There's the polite access mode, which allows a single device to transmit a message only every 100 milliseconds. So one message every 100 milliseconds. That's quite an obstacle for this. But this only applies to the short-range devices, or for the short-range devices in the 863 to 870 megahertz band. There's different regulations in the Americas. I don't think that we we don't have that restriction with the polite access mode in the US or in the Americas. Yeah. And same thing with the 2.4 gigahertz frequency. There's no restriction or there's no polite access mode on the 2.4 gigahertz channel. The sad thing about the 2.4 gigahertz is we do have less transmission power, and we do have, of course, a shorter range. But we do have a higher bandwidth for transmitting the messages. So actually, we expect to have more than 100 messages per second. But we have not tested this, of course, so I can't really tell. But we expect to be well beyond 100 messages per second. Okay, and one general thing, we think having between 250 and 1,000 devices in a channel would be the optimum use for that channel. Okay, this would be the architecture of an ISM RF device. Based upon the W2 LON transceiver, an ISM RF transceiver. We would use the Neuron 6050. We connect via the communications port, and we do have an RF front end to connect to our radio system, and of course we can connect different sensors and control devices via the I/O driver. So actually that's very near to what everybody has been doing in the LON talk world for the last 20 years. So you can basically, this means you can use your existing devices, you can use your existing software development that you had, and very easily transfer that and to a new communications channel. You need to have, of course, you need to have a new hardware design, which includes the transceiver, but when it starts to port the software of your device, that's very easy. You just need to recompile it, actually. Yes, well, as I said before, we have the 12 I/O pins. We are using the special purpose mode on the transceiver, and we connect to that with the 1250 kilobaud. There's one feature which I did not mention before. The transceiver can be updated over the air. That means we can just use the radio to update the firmware on the transceiver, which has not been possible with the traditional LonTalk transceivers, but we can do that with these new transceivers. Well, if we go one step further, this is a... So, okay, I'd just like to mention this. This is a deeper look into the architecture. We have the LON transceiver. We have a transceiver application in there which translates to the wireless stack, and we have a things interface module. So actually, we have that under control. So we are able to connect to different devices which don't need to be LonTalk devices, which can be everyday devices, but they can be mapped into this application and can be mapped as LonTalk devices. So we will be able to integrate wireless sensors which are in the vicinity of this device, and have those devices accessible just through the LonTalk protocol. Okay, so these are the current products that we have. We have the WT-LON transceiver, which is a RF transceiver for LonTalk. We have the evaluation kit for those people who would like to evaluate this and check out if their applications or what they can do with this kind of technology. And I just want to show you the architecture of that. We have a Neuron 6050. We have the transceiver on that. We have it powered via USB. You can program the Neuron via the SPI interface, and you have the access to the GPIO as well as RS-232, and this is just for debugging. Yes, and I think I need to speed up a little bit. I'd just like to show that we have this router here, which is needed for connecting to a FT channel. Of course, so this is a transparent router, and of course you could you could also connect to the RF channel just using an SMIP application on the Neuron, which is available from Echelon if you buy the LonStack kit, I think. Yes. We're working on the standardization. So we have a new work item proposal for the part 9 of the 14908 series of standards. And the work item proposal has just been approved by CTA, ANSI, and the work item proposal will be approved, so we hope within Senelec, and so we think that we have a standard at the end of this year, probably. Yes, I don't want to go through that all again. I just want to show you what you can do at the moment. We have the WT-LON transceiver, which will be available in Q3. We have the evaluation kit, which will be available in Q3. You can have a customized transceiver for your application, or WHO can also help you with a design in. So if you have an existing application and you want to have the capability of integrating that with wireless LonTalk, then we can, of course, help you with this. And for more information, go to who-ing.de/W2LON. Thank you.
Ja, danke.